Alright, in this set of videos, it's going to be quite a few. I want to delve into proof. Alright? And proof is, like, as math goes, a very controversial subject. What counts as proof? What makes something true about a problem? And math is one of the biggest topics in which this idea of proof comes up. The second biggest would probably be like crime and stuff like that. But proof is all about saying that there's this, if you have one piece of evidence or a set of evidence right here, let's just call this evidence, all right, that you can extrapolate, you can have these other ideas branch off of it that have to be true given that the evidence is true. And so you have all this facts and information. Facts and info that you unlock through it. And proof is these arrows that we draw here. Proof is the thing that allows us to get from evidence to facts and info and be certain that this facts and info that we got to is valid considering the evidence. Now, sometimes our evidence is completely false. You could make a whole set of mathematical reality in which you say 2 plus 2 is somewhere around 5 or something like that. And you could talk about all numbers as some kind of estimator or something like that, which may work for you. But it all depends on what evidence you start with and where your conclusions end up, stuff like that. And I don't know why I wrote that up, because honestly, that's still part of our normal system of doing math, but you can do math in any set of ways. So the first step is that you set up kind of some system. So let's say you're like, if I notice, like, let's see here. Let's say we have 3 dots representing 3 people, and the lines between them represent their interactions. And then we could write different tick marks on different lines to study their different interactions. And hey, these guys interact very similar to these guys, but these guys do not. So maybe we could do this and draw an X there. And already we're developing this notion of relationships between objects, which is fundamentally what mathematics is. It's all about relationships. But more than that, I really want to get at this idea of proof. It's really the hallmark of all mathematics. And it's the reason why so many mathematicians back in the day were all considered great philosophers. It's because this idea of connecting evidence to facts and information, and you could even connect it backwards. If you have facts and information that someone told you, you should be able to get the evidence back, what you started with. And sometimes we have facts and info and we don't know it. And like we know the facts and info, like, I don't know, a squared plus b squared equals c squared. And then later someone shows us like, oh, so that's why that's true. And that is going backwards with the proof and gives us evidence based off of initial facts that they tell us later. And proof is complicated, and many people ruin it. Many people, I think, ruin it. They're like, okay, here you go. Like in geometry class, everyone has to do this proofs idea, where they create a table and they're like, okay, here is facts that I know have to be true, and here are pieces of info in our problem. Let's say pieces of info, not point. Wait, what does POI stand for? Point of interest, whatever. No, pieces of info. And then we have facts like, hey, I know that ABC, triangle ABC, is congruent or whatever to this other DEF triangle because of the facts that I lay out here. And they have us organize these until our thoughts become like conclusive, and we're like, oh, we're running through this, that means this whole fact has to be true. But I think that's actually a poor way to talk about proof. I think proof is more than just the exact way to do things. I think it's also seeing why something is true. I think it's seeing that, like the infinite summation we did. So like half to the I power, and I starts at 1 and I goes to infinity. Why does that equal 1? Well, you could go through some proof where we like say, okay, well, by the half principle of numbers, or by the fact that half is less than 1, this converges to a result, or something like that. But that's boring, and it should be boring, I think, because like there's little things that you're discovering when you do it this way. But if I drew this out as a problem and said, hey, here's a distance of 1. If we go half, then we multiply another distance by half. That takes us this extra distance, then keep taking a distance. So you imagine if we go long enough, we get a complete result of 1. And that is why infinity is up here, so we can go that complete distance of 1. This is, I consider, proof. This is controversial in the sense that, like, it's not like you can go to court and argue a case and say, like, hey, it looks like they committed a crime, so good enough. That's kind of what we're doing on some analogous level. But math proof, no one has to know those minute details and how to talk about them in everyone's accepted fancy lingo. No, the point of math proof should be so people can get something from a result. Let's change pages here. So that's the idea of proof, and we're going to talk about it a lot. We're going to do a lot of proofs in the next many videos. But before that, I want to talk about how we learn. All right. There's this keyword that I think is becoming pretty popular and for all the right reasons, and it's the word intuition. Now, I'm not going to straight up define it. In a general sense, intuitive, if something is intuitive, it makes sense. So that's how I define it in simple terms. That isn't probably the dictionary definition. But hey, this isn't the mathematical proof. For the same reason that makes sense is not the dictionary definition of intuition. So intuition, shin, if you want to go into word roots, makes this a noun, so it has to be the noun sense of making sense. So it's this object that is making sense that we care about when we talk about intuition rather than something being intuitive. That's kind of the word that I think people use a lot. Intuitive. But this word is brilliant because what it talks about, however you spell it, the concept is what we care about here. However you think of it, intuition is all we care about when we learn math. When we want to have a first idea that, hey, if I have a length here, A, plus B, and I have a length here of 2, well, the area here can be thought of as 2 pieces. You have this A piece right here, and a B piece right here, and so you can think of this as 2 times the B piece. Let's do it in another color so it stands out. 2 times the B piece, and then this is 2 times the A piece. So A plus B times 2 is 2A plus 2B. Or you could think of it as 2 A's, A plus B. Same concept, and that is multiplication. But intuition is that mechanism I just used by drawing a rectangle and talking about area in that sense. That area has a very close relationship to, let's draw an arrow both ways. Area has a very close relationship to, what is the other thing? Multiplication. In fact, they're in a mathematical sense, they're almost synonymous. And you'll see that later. But what we always care about, especially when people teach things, is intuition. Because if something doesn't make sense, you're not going to use it, A, and B, you're not going to care about it, really. If something doesn't make sense, like, hey, I could repeat you the binomial theorem, but like, does it really matter if you can't understand it? It doesn't matter at all if you can't understand it. So this is that currency, basically, that of mathematics that gives value to each fact, each idea, each little proof. So that's intuition. And the last thing I just want to get into So intuition just, it gives us a framework. It's kind of a scaffolding for setting up our thoughts. And oftentimes intuition is not true. I think lots of things humans believe are unfortunately false. I think we have all the sorts of biases, whatever. I use both. We have all sorts of biases, but in a general sense, intuition at least latches ourselves onto an idea. And that is the first step to understanding it. If we can at least latch onto an idea and hold on, we can at least climb up and actually get a perspective of the world. Let's draw a person here. This is you. Getting a perspective of the world. Like, whoa, check that out. Now I actually understand what's happening, even though I used kind of a cheap little rope to get this view of the world. Let's draw some mountains, because that's something that's cool. Some happy trees. You know, all sorts of stuff. Let's draw one more. So it's all about seeing the world, and I mean that's really what math is about. It's about seeing the world as relationships and things interacting. And sometimes you do have to use these mechanisms that are somewhat flawed. And in the next video, I will go into calculus. And I haven't been necessarily teaching calculus wrong, but I wanna destroy some stuff with intuition. Now that we have all this knowledge of calculus concepts, and I recommend you go back and watch them if you're still curious. But now that we have all these knowledge of calculus concepts like the power rule and stuff like that, how do we now that we kind of are on top of it, how can we look back and see what that does? It shows us in the world. All right. So that's the big idea, and yeah. Next video I will cover calculus intuitions.